All right, Algebra 2 today, we're doing 5.2, which is graphs of polynomial functions. So to start you out, I want you to look at two different parent functions that we have studied. Our first parent function is f of x equals x squared. So the graph of this, when sketched, looks like this. It's a parabola. Our other parent function that we have studied is f of x equals x to the third. It looks like this. If you can remember these two parent functions, you will be able to do everything that we're doing today relatively easily. Okay? The important thing that I want you to notice here is what happens at the ends of these graphs. So as the domain goes towards negative infinity, or as it goes out to the left. And what happens to this end of the graph as x goes to positive infinity. Okay? So in the x squared function, both of these are ranges, okay, or our f of x values are both going up at each ends of the graph. Okay? So this little arrow means as it approaches or as it goes to. So here, as x goes this way, our range or our y value is going up. As x goes this way, our range or our y value is going down. So in this cubic function, okay, the parent function, as x goes to negative infinity or goes to the left, our y value, right, f of x stands for y, goes down. This way, as x goes to positive infinity, our y value goes up. Okay, so we're looking at end behavior of graphs. And like I said, if you can remember x squared and x to the third and what those two look like, you're going to be in really good shape for this. Okay, so here's some graphs of some polynomial functions. Okay, so notice the degrees on these ones. These are all odd degrees, and they all follow the function or the same behavior as the degree to the third power, or that cubic x to the third function. Okay, one end and the other end, one end and the other end, one end and the other end. Then we have here our even functions, and they all look like our x squared functions. They're both going in one direction. Okay, both the ends are. So that's what we're going to want to pay attention to. So now we're going to get into whether they're even or odd. Okay, these are the basic. Okay, but now we have to talk about the leading coefficient. Okay, so let's talk about the even ones first. So you guys have seen the function ax squared plus bx plus c is a parabola. If this value is greater than 0, or it's a positive number, okay, those parabolas open upward. Okay. If this a value is less than 0 or negative, those parabolas open downward. Okay, so this is going to tell you the different rules. So like I said, if you can remember the basic x squared function, then all you have to do is say, okay, well, if it's opening downward, then I know it's like a parabola facing down. Okay, it doesn't matter how many of these doo-wops are in here, and we're going to talk about the actual name for doo-wops. That's just made up and what I like to call it for right now. It doesn't matter how many of those are in there. If it's an even function, it looks like a parabola. Okay, so what that means is as x goes this way, that's what this is saying, our y value, in this case p of x, goes up. As x goes this way, our y value goes up. So as x approaches negative infinity, as it goes towards negative infinity, our y value goes up and up and up towards positive infinity. As x approaches positive infinity, in other words, as it opens this way, our y value also goes up towards positive infinity. If a is negative, it's the opposite. So as x goes this way, our y goes down. As x approaches positive infinity or goes to the right, our y goes down. Okay. So now let's look at those odd functions. So it's the same thing here. We have that x to the third function. Okay, if this value is positive, right, a positive a, then it's going to look like that parent function. The way I like to remember this is the end goes in the a direction. Okay, so if a is positive, then the end of my graph, or the right side of my graph, okay, I call it the end because we always work from left to right, remember? So the end goes in that direction. If a is negative, okay, in other words, it's a reflection, okay, then it goes down. It goes towards the negative. Okay, my y value does. Here, my y value went up. Okay. So if you can remember what these two basic parent functions, x to the third and x squared, look like, you can do any of these. Okay, it doesn't matter if it's x to the 9th power. If it's odd, the ends are going to look like this or this, depending on your a value. Okay, so you need to know that. So here, if it's an odd function and a is positive, then I know that as x goes positive, my y goes positive. And as x goes negative, my y goes negative. Same here, right? I'm going to look at the end. Okay, so if my a is negative, then my y goes negative as my x goes positive. As my x goes negative, my y goes positive. Okay, so it always ends in the direction of a. So if a is negative, it ends going down. If a is positive, it ends going up. Okay, important things to remember. Okay, so let's go ahead and let's look at a couple of problems. Okay, this is going to get into how we graph these things. Okay, because you're going to have to be able to graph these things by hand, or at least know how to, and know what happens in them. Okay, so the very first thing I'm going to look at is I'm going to look at whether it's odd or even. So to the 4th power means it's even. Okay. The next thing I'm going to look at is my leading coefficient. And I don't care what the leading coefficient is. And the same with, I don't care what number that is. I just want to know, is it even or odd? So my leading coefficient is negative. So a is negative, okay, or less than 0. So if it's even, right, it's going to follow that x squared pattern, which means it looks like a parabola, but in this case, it's negative. So that means it's going to look something like this. Okay, so now I have to write down what happens. So we're going to look first at this side, the left. So as x goes to negative infinity, in other words, as it goes to the left, my y value, my f of x, also goes to negative infinity. So here my y goes down. Okay. On this side, as x goes to positive infinity, my y value goes down. Okay. So that's what I'm looking for when I'm talking about the end behavior. These things need to be written down. Okay. As x goes to negative or positive infinity, what happens to y? Okay. That's my end behavior. Okay, so let's take a look at the next one. So the next one is odd. Okay. So it's going to be an x to the 3rd function, and my a is positive. So it's a normal, okay, or positive. Okay. So I know that in that case, that means that it ends in the direction of my a. So the right side ends in that direction. Okay, so now I can write my end behaviors here. So I'm going to start to the left. So as x approaches negative infinity, and you see I draw these arrows so I can refer to them. So as x goes to the left, so that's this one, my y value goes down. Now I'm going to look at this one. As x goes to the right, my y value goes up. Okay, so my end behavior, what's happening? Okay, so this one right here, it actually gives us a graph, and we need to find out, is it even or odd, and is our leading coefficient positive or negative? So if they end in opposite directions, it's going to be odd. And remember, it always ends in the way of the leading coefficient. Okay, so it's going up in the positive direction. So my leading coefficient is positive. Let's look at some guidelines for graphing a polynomial. Okay, so you're going to be able to do this completely by hand shortly, but for now, you can't. You can't do it all by hand. Okay, but there are some things that we can do by hand. So finding the real zeros and the y-intercept. So the y-intercept is going to be there. So our y is -8. Okay, so y-intercept is 0, -8. Okay, so I can plot that point on there. I also know that this is an odd function, and my a is positive. So it's positive and odd. So I know it's going to look like that. Now I can plot some points in there and see what's going to happen. Okay, but that kind of takes a lot of time right now because you guys haven't learned how to find the real zeros yet. Okay, we will do that, and we will do that relatively soon. But for now, I want you to just come into your calculator and let's graph it. Okay, so if you're unsure how to graph it, I'm going to show you how, just so that you can use this. And I do have some calculator tricks, a calculator cheat sheet in Google Classroom. So make sure you use that because it will help. Okay. So here I'm going to push X. So my X is this, let's see if I can get it. So it's showing this X button right here. Okay, you don't have to use this alpha every time. This is your button that you can use for any variable. Okay, it doesn't matter if it's X, Y, Z. Okay, if you have just one variable in there, you can choose whatever letter, right? Sometimes you guys say, oh, Ms. Nielsen, it's an R, but I put an X. Is that okay? Yes, that's okay. Okay, so now that's an X. Okay, it's raised to the third power. So if I'm raising it to a power, I can use this little caret key. So I'm going to do that. And you can see it put that in there to the third. Okay, now I can enter the rest of it. So plus 3x squared. So I'm going to hit my plus key. And now I'm going to hit 3. I'm going to hit this key again. And my squared key. Okay, you can use your caret key too if you want, but this is a shortcut. Okay, so you could do that. You could do this one again and then a 2. Okay, and then I'm going to do minus 6x. And remember, okay, this is minus. This is the minus key. This is if you're making a number negative. You cannot intermix those. Okay, and watch what happens when I do. So I'm going to go on ahead and I'm going to put the negative key in there and pretend that we don't know. Okay, so I made a mistake, but we don't know I made it. And now I'm going to do my minus 8. Now watch, I'm going to hit graph. Okay. And in this case, it graphed it, but it did not graph it correctly. Okay. And if I go in here and I look at this, okay, I can see there's a difference. This one's smaller than that one. Okay. And a lot of times also, if you go in to graph it and it's wrong, okay, it'll tell you error. And then it has 2 options here. It has a go to or it has a quit. Okay, if you choose that go to, it's going to tell you where your error is in here, and that cursor will be blinking on that. Okay, so use that. If your calculator says, hey, there's an error, look at it, hit the go to and see what it points you to. It's going to show you where you've made an error entering this thing. 9 times out of 10, it's someone put a negative sign in instead of a subtraction sign. Okay, so now let's look at the graph when I graph it correctly. See, much different. Okay. All right, so now we can look at this and we can see where this thing crosses the axes. Okay, so we can either look at it and say, oh, well, that looks like -1, 2, 3, 4, and -1 and +2, or we can hit second graph, open our table up, and we can see, yep, -1, 0, -4, 0, and 2, 0. Okay, so now I can graph those points. So at -4, 0, -1, 0, and 2, 0. And now I know that it starts down here. It comes somewhere up here, I don't know where. Crosses somewhere down there, and then it comes back up. Okay, and I just sketched it. Okay, if we wanted to find out where in here, we could plug in -3, okay, or look at our table and say, oh, -3 is 10, right? And then I could do it exactly. And we're going to get to where we do this more exactly. Okay, for now, I was just kind of estimating. I don't like how ugly that is. So for now, I was just estimating, okay? But in just a minute, we're going to learn how to find where these doo-wops are. Okay? So we can use our table, definitely, okay? But we can also plug some points in if we want. All right, so this next one, let's go on ahead and look at it. So this is my y-intercept, 0, -6. Okay, so I'm going to go on ahead and graph that. Now I know that this is odd and it's positive. So I know that it's going to look like that. Okay, my graph is, okay, my ends of it. Okay, and now I can come in here and I can graph it. And I can say, okay, x to the third plus 4x squared plus 6 minus, plus x minus 6 graph. All right, so that one is looking pretty good, but I know right from looking at it, my y-intercept is off, okay? My y-intercept should be at 0, -6. So I'm going to come in here and see what I did wrong. Oh, look, I put that negative sign again instead of a subtraction. So I'm going to change that to subtraction and I'm going to graph it. And this is why it really is important for you guys to understand some of the stuff on these graphs. Just like in a parabola, this last constant is always your y-intercept. Okay, so even in my cubic function, okay, it's telling me where it crosses that axis. Okay, and then I'm going to use my table to find some other points. So second table, okay, and I can say -3, -2, and 1 is where it's going to cross. So -3, -2, and 1. And once again, if I wanted to find a couple other points, I could. So at -4, it's at -10. Okay, so it's going to come up here. It's going to cut in there. It's going to come back down somewhere and cut back up. Okay, right? And it's not exact, okay? I just kind of guesstimated. Okay. All right. So now how do we find out where these actual points are? Well, when we were looking at parabolas, right? And we had a parabola this way, this was our vertex. So if our vertex was -7, 3, okay, this right here corresponded to my y value and it was my minimum value. Okay. If I had a parabola that was going this way, okay, I had a maximum wherever this was. So we'll call this 7, I don't know, 18, right? And this would have been my maximum value. So we've learned about end behavior. For end behavior, we're looking at the very ends as these ends approach infinity. But we have these in here that look like these parabolas, okay? These are called turning points. So a turning point is where a graph changes from increasing to decreasing. So it changes from increasing to decreasing, meaning from going up to going down, or from decreasing to increasing, so here to here. Okay? A turning point corresponds to a local maximum or a local minimum. So just like in our parabola here, this would be a local maximum or a relative maximum. This would be a local minimum or a relative minimum. We also call these local or relative extremes or extrema. So more than one maximum is called maxima. Okay, more than one minimum is called minima. Okay. So looking at this, a couple other things we can tell. Okay, if a polynomial has degree n, in other words, this one right here is x to the third, this one that we just did. So x to the third plus 4x squared plus x minus 6. We're looking at this, and this is our n value. Okay, when we started talking about polynomials at the very beginning of the class, we talked about it in terms of a to the n plus a to the n minus 1, right? So it started with 3, and then it subtracted 1, subtracted 1, subtracted 1, okay? So this is our n value, okay? A polynomial can have at most this many turning points and at most that many x-intercepts. In other words, this one can have 3 x-intercepts at most. So you see here, 1, 2, 3 x-intercepts. And it can have at most 2, because that's 3 minus 1, okay, turning points. In other words, local maxima or minima. Okay. And we're going to use a graphing calculator to estimate these values. So let's look here. So the first one, how many x-intercepts can this have? So this is a 3, so it can have 3 x-intercepts at most. Okay, doesn't mean it has to, but that's the maximum number it can have. Okay, and actually it is going to have, I lied. So it is going to have 3 x-intercepts. Okay, but you'll see as we progress that sometimes they repeat. Okay. So it can have at most 3 minus 1 turning points or local maxima or minima. Let's go ahead and graph this function. So it's going to be 2x to the third minus 12x plus 6. Okay, and if we graph it, we can see that it has 1, 2, 3 x-intercepts, and it has 1 up here and 1 down here turning points, so 2 turning points. And remember, for this one right here, that's a most. Okay, that's the most it can have, and the x-intercept is exact. So now we're going to do the steps to find our turning points. We're going to start with our maximum. So our maximum is somewhere way up here. So on our calculator, we're going to push the blue second button. So second, and then we're going to push the trace button, which is actually calculate. You notice here, it gives us a way to find some values. Okay? We want to find our maximum. So we're going to hit number 4. Now it says, hey, what's my left bound? Okay, so what that means is I need to go somewhere a little bit to the left. So my left bound. So if I have my graph here, I need to go somewhere a little bit to the left, okay, of this. And you can see I'm going until I can see my cursor here on the left of that maximum there. Okay, then hit enter. Then we're going to do the same. Now it says, hey, what's my right bound? In other words, how far to the right does it want me to go? And this, what this is doing is, you see it put an arrow there. It's giving me a spot where my graph can, let's see. So I'm going to come over this way a little bit so that you can see this other arrow. So it's giving me, hold on. We'll put 1. Okay, so you can see it's giving me some arrows here where I want to be between. Okay, so I want it to find the maximum point between these 2 arrows, because sometimes if you have 5 or 6 of these, you're going to have to tell it, well, which maximum do you want? Okay, and then it says, hey, do you want me to guess? Yes, I do. So I'm hitting enter. And now it tells me where that maximum point is. So I have this maximum at negative 1.4 and 17.3. It would be really hard to use a table for this, because you would have to figure out what increments to put our x's in. And in this case, we would have to put it in increments of like 0.1 or 0.01 to get to that maximum. Okay. What we can see here is that we can see it's down at negative 12, and then it goes up to 16. You see, it doesn't even give us that. It goes up to 16, okay, 14, and then 16. So we would think that it's somewhere in here, but we wouldn't know where. Okay, so this is just a tool. So now we're going to go to second trace, and we're going to do the same exact thing with our minimum. So with our minimum, we're going to choose number 3 or scroll down to number 3 and hit enter. Okay, so now my minimum is here. I need to scroll to the left of it, and you can put an X value in here too, right? So I could put X equals 1, enter, and it puts my left value there. Okay, but you have to be careful because you see how close I was to that. If I was a little bit too far off, then it wouldn't find my minimum down there. Okay, so now my right bound is going to be somewhere over here. Okay, so I'm just going to scroll past it, and it doesn't matter. You can scroll anywhere past it as long as it's past where that minimum value is, where you can actually see that. Okay, so now it says, hey, do you want me to guess? Do you want me to find a minimum between these 2 arrows? Hit enter because yes, you do. So my minimum point then is 1.4 and negative 5.3. So we can use our calculator to do that. Okay. So let's go on ahead and let's take a look at this next problem. Y equals x to the third. You guys need to get very proficient at using your calculators. It's very important. So we know that this is going to have 3 x-intercepts. And remember I said, sometimes it might not look like it has 3 of them because sometimes it repeats, okay? So this one right here is probably a case of that, okay? And I'm just gonna come in here and double check that I typed it in right because I just wanna make sure x to the third minus 2x minus 3, okay? And then this one has 2 turning points at most. So now let's go on ahead and let's find out what those are. So I'm gonna hit second, calculate. Okay, and I'm gonna, it doesn't matter. I'll start with my minimum this time. So I'm gonna start with my minimum. Okay, so my minimum's over here. So a point to the left of it. And I need to go a little bit to the right and hit enter. And then if I hit enter again, it's gonna tell me where that is. So my minimum is at 0.82, negative 4.1. Okay. So now I need to do the same thing for my maximum. So my maximum, second, calculate my maximum. And I need to go to the left of it, somewhere over here. And I need to go to the right of it a little bit. Okay. So now there's my arrow. So it's looking for the maximum point between those 2 arrows. And I hit enter and I get negative 0.82 and negative 1.9. Okay, so that's how you find those maximums and minimums. Okay. All right, so look at your calculator help sheet. It gives you tips on how to do this. It shows you how, or it walks you through the steps. Okay, keep in mind, you guys remember that this blue key here is so that you can push any of these blue buttons anywhere on here that you see. The green key corresponds to any of these green parts that you see. Okay, you guys need to become familiar with your calculator and how to use it because it is going to help you a lot. Okay, have a great day and I will see you guys next time.